I'm Chris Anderson at the EU Web Tech Lab, where today we'll be looking at the IDT Versamixer. Versamixer is a wideband, low-powered mixer available in single or dual channel configurations. It can cover RF and IF bandwidths of 400 MHz to 3.8 and 3.6 GHz respectively using a single BOM, letting RF designers deploy the same mixer across a range of technologies. The mixers feature IDT's flat noise and zero distortion technology. Flat noise keeps the noise figure virtually unchanged as gain is reduced from its maximum setting, giving designers more flexibility by providing the best SNR possible. Zero distortion reduces third-order intermodulation distortion by approximately 90% to improve coverage, quality of service, and spectrum usage. For the demo, we have the evaluation board with the dual-channel mixer, but we'll be using it with just a single channel, so I'll hook that up and we'll get started. So at the center of the board, we have the Versamixer IC. We have the RF inputs for both channels, the IF outputs for both channels, and then the LO input. This is just the DC voltage input, and these headers are for setting the gain and disabling channels. Now we're only going to be using a single channel, so I've terminated both the RF input and the IF output for the second channel. And since we're using test equipment, we have these 4-to-1 balance. Normally the IF is a 200 ohm differential output for driving things like pre-ADC filters and keeping distortion very low. But again, since we're using test equipment here for evaluation purposes, we have a 4-to-1 balance to bring that down to 50 ohms. These headers over here are for setting the gain as well as disabling individual channels. Now since again we're not using the second channel, I'll go ahead and disable that, and we'll see the current drop from its current setting of about 225 milliamps down to about 127 milliamps. Obviously that will change once we apply signals, but you get the idea that there is roughly a 50% power savings by disabling a single channel. All right, so with everything connected, I have my two synthesizers. This is connected to the RF input, this is connected to the LO input. I'll set the RF to 1000 megahertz and the LO to 800 megahertz. I've got my spectrum analyzer set to a center frequency of 200 megahertz to capture the IF output. Now these are uncalibrated, but they're both set to about plus 6 dBm. It's as low as they'll go. And the gain settings on the eval board haven't been changed, so that should be sitting at about 11 dB. So we should see a signal somewhere around 17 dBm here. So if I turn my RF outputs on, we have our 200 megahertz signal, and it's sitting just under 17 dBm. Now I can go ahead and change the outputs to 3600 megahertz, kind of go to the opposite end of the range, 3800 megahertz on the RF, turn those back on. And of course we don't change the spectrum analyzer because we're still 200 megahertz. And you see that our signal has dropped just slightly, but to cover that range with a pretty flat gain across the entire spectrum, and we didn't change anything on the BOM. That's one of the really impressive things about the Versamixer. Now what's not apparent on here is if we change the gain, and we can do that by shorting some of these pins together. If we go ahead and reduce this gain, what you don't see is that that noise figure stays very, very flat. So even though we dropped the gain from about 11 dB to, I think the minimum setting is 2 dB, the flat noise technology that IDT has developed keeps that noise figure very flat. And also the zero distortion technology maintains that very, very low third-order intermodulation distortion. IDT's Versamixer family is just one example of the products in IDT's RF portfolio. In addition to zero distortion and flat noise, IDT offers additional innovations across their RF portfolio, including constant impedance, constant linearity, and glitch-free operation. For more information on Versamixer and other RF products, visit IDT.com.